section 2.2, and in case you missed class, you're absent maybe right now watching this, I think we started off with a little math puzzle. So if we have a calculator handy, feel free to pause the video as needed, but first thing you're going to do is type in your street address number, whatever it might be. So your street address number, and then you're going to add 9 to it, and then whatever you get, you're going to multiply that by 2, and then whatever you end up with now, you subtract 4 from that, and then when you get that answer, divide it by 2, and then subtract your original street address number from that. So you're always updating the answer as you do steps 1 through 6. Remember, pause the video if you need to, because we're about to blow your mind, because I know what your answer is or should be, and it's 3, 2, 1, 7. Your answer 7. How do I know that? Well, I guess, math. And just to cut to the chase, I'm sure we probably dragged this out a little bit more in class, but, because you're probably thinking like, well, wait, how could everyone get the same answer of 7 if everyone probably typed in like a different number to start with? Well, I guess how algebra comes into play in math is like when something's not known, or when something can vary, or be a number that could be a lot of different numbers, or any number, we use a variable, which is just a letter or whatever that can take the place of a number that you don't know or can vary. And so if we use x, right? So here's kind of what happened. You picked a certain number, and it looks like, I hope I'm not wrong about this, I don't want to go back, but it looks like everyone had this number x, okay, this some number, and everyone added 9 to it, and then they multiplied it by 2, and then they subtracted 4, and then they divided by 2, and then they subtracted whatever that x was. And it turns out that no matter what x is, you could like leave it as x, you could just leave this as a letter. When you simplify this crazy looking fraction over here, the whole side here, it's always going to equal 7, and that's just algebra. In fact, I don't know if this is sort of not a waste of time, but I don't know if it's like kind of getting off track. But if I distribute, I get 2x plus 18. And then what I should probably do next is 18 minus 4, which is 14. And then, see, again, like I was saying, we might be getting into algebra concepts that are a little bit ahead of schedule for us, like we might be getting ahead of ourselves. But what you can do with this fraction is we could do the 2x divided by 2, and we should also do the 14 divided by 2, and 2x divided by 2 is 1x, 14 divided by 2 is 7, and I think now you can pretty much see how this is going to end, where, x minus x, that'll be 0, and you'll end up with 7, you know what I mean? So this whole side just ends up being 7, so, Anywho, there's another puzzle that I don't know if we'll be able to do or not. This web address has, every year it's like, I don't know, it acts funny, or maybe this actual web address doesn't exist anymore, or it can be kind of weird. Anyway, let's get down to business, real business. Definition of a variable. I've already sort of touched on this. Pause the video if you need more time to write this down, but it's a letter in math representing an unknown number. So it's an unknown quantity, which could be a certain number, like it's only, a variable could be only one number, it's just unknown. Or a variable sometimes represents any number. Like remember, it can vary. It can represent a number that can vary and be a whole bunch of different numbers. Example, like we could, for the number of days, say it's like an unknown, like it could vary, or everyone has a different number of days they're absent. We could just use the variable d for this unknown number of days, whether it's 5 days absent, 7 days absent. Hopefully not, a whole lot of days absent, but we could say like the number of hours you will work on homework. It's unknown, it can vary, so we can just fill it in with h. H could represent it, and then T would be maybe the temperature outside. It's unknown on different days. It varies. You know what I mean? Variable expression. Well, I mean, there's not much mystery here. It's essentially an expression that involves variables or a variable. So I guess what I should say is there's definitely a difference between an expression in mathematics and an equation. An equation has to have what? It's got to have a what? It's got to have an equal sign. So expressions don't have equal signs, essentially. But a variable expression has letters, numbers. There could be some addition involved, a plus sign, a minus sign, other operations, whatever. Example, 5t is an expression. That's an expression. 6z plus 92, that's a variable expression. 4 minus b over 3. All variable expressions. Notice how there's no equal signs. And again, always pause the video if you need to. Hint, I don't know if is hint the best word right now? Hint. But it's more of like a... it's more of just a fact. It's more of just like a thing that you need to know. We will no longer be using this, elementary school symbol for multiplication. And I'd be shocked if, like I know in 2018 I've already addressed this in class already, but on whatever, it's not 2018, different year. I'd be shocked if I didn't already point this out, that we're not really looking to use this symbol anymore. I know I'm a hypocrite. We just used it in scientific notation last class, but anyway, like I was saying, again, I don't know. Like this year we did, the last section was scientific notation, but just in case it's different. All I'm really saying is that yes, we still sort of use this symbol in scientific notation, but I can't think of any other situation where it'd be normal to use this symbol. Like we're trying to get away from that symbol because it can look like the variable letter x. So instead we're going to use the dot, just parentheses where two numbers are next to each other, or just no symbol at all, like 5n. If it's 5 directly next to the n, that means it's 5 times n. Write a variable expression based on the statement, sentence, whatever. Jan works 8 hours a day and earns $7 an hour. I mean, what kind of variable expression could you write from that? H hours a day. Like, how could you put H hour, like H, and 7 together to make an expression. Like, how would they even go together? You know, hours a day and dollars per hour. How do they go together? You know, don't you normally multiply them together? Ooh, that's not, gotta lock that down. Anyway, $7 every hour for H hours. Don't you normally multiply those two quantities together, and that's going to be like your total pay for that day? You know what I mean? If you worked 3 hours that day, wouldn't you do 7 times 3 to get your total pay? If you worked 7 hours, wouldn't you do $7 times 7 hours to get your total pay? Well, you know, just treat H like a number. 7 times H. You're still doing dollars an hour times hours. So here's the variable expression, 7H. Number 2, Nate can solve a math problem in 3 minutes. A variable expression. Well, I guess we would need a variable. What would be the variable here? You know, I know this isn't like as clear as crystal or as clear as can be, but what would be like the unknown variable here? Wouldn't maybe we could say it's the number of math problems? You know? So what variable do you want to use? Do you want to use M? Do you want it like for math problems? Do you want to use P for problems? Do you want to use N for like number? You know, those are probably like the best ones. I mean, X, some people just use X all the time. I'm going to use N just for number of math problems. So I guess how would you make an expression with an unknown number of math problems and like the number of minutes it takes to do each one? You know, wouldn't you also multiply those together? 3n, and that was going to represent like the what? What would that be? 3 times n would be, it'd be the total number of minutes for all the math problems, all the n. Like if n was 5 math problems, it'd be 3 times 5 for 15 total minutes. Whatever, but you know, it's n, so we still do 3 times whatever, n. Last thing, I do believe, evaluate. Evaluating just means that the variable will be a specific number, and they'll tell you, and then you just give the value, the final value, right? So we're going to evaluate these if x was actually 2. Well, this is really easy. We can just plug in 2 for x. If x equals 2, then 3 times x becomes 3 times 2, which is 6. And then in this expression, x plus 5 becomes 2 plus 5 if x is 2, and you're just replacing the x with 2. 2 plus 5 is 7. And then 9 times x plus 2 becomes 9 times, what was x again? 2 plus 2. Now, a little bit of order of operations here. You multiply, and then you add in that order. Yeah, 9 times 18. So the final answer would be 20. And, well, I guess I was wrong. From the worksheet. So this is from like our homework assignment. I do believe these problems are asking about perimeter. I'll do one in the video. You know, I mean, you got to do some work yourself. I bet in class I only really did one. Anyway, for you. But number 15 is probably the same number on your homework. And it's this exact same problem. And I think the directions are find the perimeter. What does, well, first of all, what does perimeter mean? Isn't perimeter the sum of all the sides? Like when you add up all the sides of the shape you're looking at? So, or the distance around the outside of the shape. So if from here to here is x, and from here to here is 1, and from here to here is, so it looks like these are squares, 1 by 1 squares. Well, wouldn't from here to here be a 1, and wouldn't here to, if these are all the same, right? I mean, like, because this is 1, right? It's kind of, this one sort of comes down to, and then, right? So 1 and 1, and then from here to here, wouldn't that be x? And then wouldn't from here to here be 1, and from here to here be 1, and okay. So now we just have to add all this up, and I guess I maybe should write that one too. Now you just add them up. So 1 plus 1 plus 1 plus x plus x, whoa, sorry. 1 plus 1 plus 1 plus x plus 1 plus 1 plus 1 plus 1 plus 1. Anyway, all the ones you can add together, 8, 10, I think it's 10. It's 10, right? Yeah. And then these x's, what's x plus x? Well, I hope you know it's 2x. So we can add those together as like terms, and all the ones add together as like terms, and this would be your final answer. Because you can't add 2x and 10. They don't mix. They're not alike. They don't add together. So the final answer for number 15 is going to be 2x from the x plus x, and then the 10 from all the ones. And that's it for 2.2.